Hey, good morning. Welcome to the 2020 Earth Science School year. I am Mr. Livesey. I teach Earth Science. I also teach some physical science and AP Physics as well. But a lot of today, guys, I'm sure you're getting lots of rules and regulations and what you can't do and what you have to do. I'd rather just kind of launch into things and just kind of get you learning right off the bat. And we'll kind of clean up some of those messes a little bit later. So here's what we're going to talk about. First thing, I would ask you to pull out a notebook if you've got one nearby and a pen, and you can pause the video if you need to take a couple seconds to do that. And the reason I have you guys take notes on something that's actually in front of you is that you actually process the information a little bit better and understand it better by virtue of the fact that you're writing it down. You actually understand it about 3 times better. So just take the time to pull out a notebook and take some notes along the way here as we do things. It won't be a lot of notes today, guys. We're going to ease into it. But today's objective that we're going to start talking about, since we're talking about Earth science, but it's actually technically Earth and space science, we're going to start talking about the Earth's rotation today. And so we're going to kind of define that term and kind of look at what that means for us in terms of how we're oriented on Earth here. Okay, so the first thing we've got to consider here is that there's a difference between rotation and revolution, and some people sometimes confuse those words. We're dealing today with the word rotation. And when we talk about rotation, we're talking about the Earth spinning about a tilted axis. Okay, the Earth is not straight up and down in space, at least compared to the sun. It's on a tilted axis, and this is going to have some ramifications when we start talking about the seasons. And we are always going to orient our Earth with the North Pole being on top of the Earth, even though if you were an alien traveling in a UFO to Earth, there is no up, there is no down. It's just by kind of history that we've always done it this way. So put the North Pole on the top, and the Earth is going to be rotating about this tilted axis here. And we're going to demonstrate this here in a little bit. When you do this rotation, when the Earth does this rotation, it takes 23 hours, 56 minutes, and 4.1 seconds to complete one rotation. Now, you might say, well, geez, Mr. Livesey, that's awfully close to a day. Well, a day is exactly 24 hours. It's just that the Earth is moving around the sun while it happens, so the Earth has to spin a little bit more. So we're going to say that one day here is going to be 24 hours, not 23 hours, 56 minutes, 4.1 seconds. Because in order to get the sun back directly overhead, it does take 24 hours to do that. So if you're looking at the Earth in space, half of the Earth is illuminated at any given time. So 50% of the Earth is going to be bathed in sunlight. 50% of the Earth is going to be in darkness because it's going to be in the shadow of the Earth, at least from the perspective of the sun. And so it's the rotation of the Earth about its axis that's going to give us our day and night. So 12 hours, the Earth will be illuminated, 12 hours will be in darkness. Now that's going to change a little bit depending upon the seasons and your latitude, and we'll get into that in a little bit. So the Earth's axis is actually tilted at about 23.5 degrees. That's about how much it is off its axis. And actually this is kind of important for us and our seasons as we kind of get going along here. As we kind of look at this is a little bit messy right now. We'll kind of clean things up. So take it from this perspective here. Let's look at this as being the sun and these as being the rays of the sun. Kind of, they're going out all directions towards space, but we're only going to consider the rays heading towards Earth. And the Earth is going to be rotating about its axis here. Now this NP represents the North Pole. Okay, we're looking down on top of the Earth, and the Earth is rotating. So let's imagine this red dot represents an individual standing on Earth. So if they are on this side of Earth compared to the North Pole, we're looking above the Earth's North Pole, and the sun's rays here, it would be noon for that person. And the Earth is going to rotate these 360 degrees throughout the course of a 24-hour day. So it rotates about 15 degrees every hour of the day. Now, if you're standing on the Earth's equator, that means you're spinning through space at about 1,000 miles an hour around the equator as the Earth rotates. Here, about Red Wing or so, we're moving about 700 miles an hour as we rotate through space. But you'll notice that as we spin, we're going to spin through the afternoon from west to east. And if we were on the opposite side of the Earth from the sun, that would be our midnight. And we have these kind of times throughout the day. And this will make more sense as we kind of orient ourselves in space. Now, I'm going to do a little bit of kind of visual demonstrations to help show this. And you'll click on a second video to see that. And then there's going to be some computer simulations I'm going to ask you to try that will kind of help cement the idea for you. Either way, it's been a pleasure to meet you today and look forward to seeing you in class. Talk to you soon.